began to accelerate. The MD-81 lifted off the ground shortly thereafter, starting a gentle climb from wintry Stockholm. These were the last few peaceful moments on board Flight 751. Only 25 seconds later, as the airplane was crossing an altitude of 1,100 feet above the ground and entering a cloud layer, a series of loud bangs coming from the tail section shook the entire cabin, alarming the pilots. "I believe it's the compressor stall," the first officer noted, correctly identifying the problem with the right engine during the liftoff. Subjected to the weight of the aircraft and the aerodynamic forces involved, both wings flexed upwards, breaking the clear ice that had not been removed. Lifted up by the flow of the oncoming air, the ice flew straight into the tail-mounted engines of the MD-81, entering the compressor section. As its name suggests, this section is responsible for compressing the incoming air before it is mixed with fuel and ignited, producing thrust. The compression is completed using a series of blades that rotate at high speeds. Therefore, a constant and uniform flow of air into the engine is critically important for optimal operation. At a rotational speed of 8,000 revolutions per minute on takeoff, it does not take much more than a brief contact with a small piece of ice to cause severe damage to the compressor blades, creating small cracks within the blades or even bending them. The resulting disruptions in the airflow, known as a compressor stall, significantly affect the pressure supplied to the combustion chamber. If not resolved in time, the difference in air pressure between the compressor and the combustion chamber can cause the airflow to momentarily reverse and push in the opposite direction. This phenomenon is known as an engine surge. These surges can worsen the disturbance in the entire combustion process and produce the loud bangs that were heard by everyone on board Flight 751. Compressor surges are somewhat similar to a backfiring car engine, with one major difference. If a compressor surge is allowed to develop further, irreversible damage and a complete failure of the engine may occur. Assessing the situation and aiming to limit the damage from the compressor surge, Captain Rasmussen pulled the thrust lever of the right engine slightly back to reduce the pressure differential within the engine and stabilize the airflow. Yet,